Welcome back. In this video, we're going to go over how to derive the quadratic formula from the standard form of a quadratic. If you need a quick refresher, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to take the standard form of a quadratic and we are going to use the completing the square process to derive this formula. The standard form of a quadratic is ax squared plus bx plus c is equal to 0. The first step in deriving our quadratic formula is we are going to subtract c from both sides, and that will give us ax squared plus bx is equal to negative c. Next, I want my x squared value to not have a coefficient on it, so I'm going to divide everything by a. So we'll divide that by a, divide by a, divide by a. And that will give us x squared plus b over ax is equal to negative c over a. Now we can do our completing the square process. For completing the square, we are going to take, if you remember, 1/2 of the b value, that's this value here, and then we're going to square it, and that becomes the constant that we add in here to make a perfect square. So let's do that. 1/2 of b over a is going to be b over 2a, and then we're going to square it. So we will add to this side b over 2a squared, and on this side we will also add b over 2a squared. And when we add those in, it will leave us with x squared plus b over a x plus b over 2a squared is equal to negative c over a plus b over 2a squared. From here, we'll go ahead and factor the left side and simplify the right side. So factoring out the left side, we're going to get x plus b over 2a squared. And let's simplify out this right side. We'll have negative c over a plus b over 2a squared. Let's distribute the square onto here. So this will become b squared over 4a squared plus negative c over a. And then in order to combine them, we need common denominator. So we need to multiply this numerator by 4a and multiply the denominator by 4a. And I'm also going to switch the order of these because our commutative property of addition says it doesn't matter what order we do it in, but this will allow us to have a subtraction instead of a negative plus a positive. So we'll have a b squared over 4a squared on the left minus 4 times a times c over 4a squared. And from there, we can add the numerators, or in this case, subtract the numerators. We'll have b squared minus 4ac over 4a squared. Wonderful. We're going to take this and we're going to substitute it in up here because it's just a simplified and combined version of that right side of the equation. So let's remove all of this. And let's move this up to take its place. There we go. Now, we need to continue working to isolate x. The way that we're going to do that is we need to square root both sides of our equation. And since we have a variable inside this square, we need to make sure that we have a plus or minus on the right side whenever we take the square root of it. So now we will have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. One of our wonderful exponent properties is that this radical here can be distributed onto the numerator and the denominator. So that means that this expression is the same as having a square root in the numerator and a square root in the denominator. The square root of 4a squared is 2a. That means that we can simplify out our denominator to 2a, and we now have x plus b over 2a is equal to plus or minus square root of b squared minus 4ac divided by 2a. And last but not least, to isolate our x value, we need to subtract b over 2a from both sides. And that will give us x is equal to negative b over 2a plus or minus square root b squared minus 4ac over 2a. And since we have a common denominator, we can combine the numerators and be left with negative b plus or minus the square root of b squared minus 4ac all over 2a. That's all I've got for you today. If you found this to be helpful, consider liking and subscribing, and if you have a topic you would like for me to cover in the future, leave it down in the comments below. As always, have a fantastic day.